Okay, so last lesson we looked at something called the greatest common divisor, and that was the biggest number that would divide into both of our integers. Now we're looking at the lowest common multiple. So what this is the lowest number that two non-negative integers will both divide into. We write this as square bracket a comma b, and that's in contrast to GCD, which is rounded bracket a comma b. When we see square brackets, we think LCM. When we see rounded brackets, we think GCD. In the same way we had 3 methods to solve for GCD, we have 2 to solve LCM. The first one is an array of prime factors. And the second one is actually using our GCD. So I'm going to do both these methods over here, and we're going to start with the array of prime factors. So I'm going to go ahead and I'm going to draw 2 factor trees, which we should know by now, and then we'll use our factor trees to solve our LCM. Okay, so once I've done my factor trees and I've expressed both numbers as a product of their primes, what I then look for is the highest power of all prime factors. And so I come down and I look, okay, so I've got 2, 3, and 7, and whether they're common or not does not matter for LCM. If this had a 13, I would still use it. So I've got 2, 3, and 7 here, 2, 3, and 7. I have 2 cubed or 2. So I'm going to take the highest of those 2. I then have 3 or 3 squared. So I take this one. And then I have 7 squared or 7. So I'll take 7 squared. My LCM is then 2 cubed times 3 squared times 7 squared, or 8 times 9 times 49. And you'll then have the answer to that. And that's how you use an array to solve for LCM. The important thing to note is that you look for the highest power of any prime factor. It doesn't have to be common, just any prime factor. So now I'm going to go ahead and I'm going to show you how we use GCD to solve our LCM. So here we have the rule for using GCD to find LCM, and it's square brackets a comma b, which means LCM of a and b is equal to a times b divided by the GCD of a and b. Now, we used the numbers 48 and 64 last lesson, so I'm going to use them again because we know what the GCD is, and we know that the GCD of 48 and 64 is 16. So we can then take our rule. The LCM of 48 and 64 is equal to 48 times 64 divided by 16. And we get that the LCM of 48 and 64 is 192. So that is the lowest number that both 48 and 64 will go into. We found that by first getting our GCD, which we'd have to use the methods we learned in the last video, and then using our GCD in our rule, which is AB over GCD of AB. Those are the 2 ways you can solve for LCM, and we're going to be looking at both GCD and LCM in word problems and how we can use them in practical aspect.